Hello, I'm Matt Galloway, and this is the Current Podcast.
Well, I think it's happening.
If we don't act now, it's going to be too late.
I'm afraid that time has come and gone, my friend.
What can we do?
Save as many as you can.
Goodness, that is the trailer from the 2004 movie The Day After Tomorrow. That film depicts a world in which key ocean currents suddenly collapse, leading to catastrophic climate change in just a few days. The film is fiction, so it gets all sorts of things wrong. But the premise is based on a real thing in real science. The Atlantic Meridional Overturning Circulation, basically a conveyor belt of currents that moves warm water northward. It's known as AMOC. It's part of what gives Europe its milder climate, and it's weakening in recent decades. Scientists are worried that climate change could lead it to slow significantly or perhaps even shut down. This, as you can imagine, would have serious consequences for rising sea levels, weather around the world. We will hear in just a moment about an idea to save the AMOC by building a dam across the Bering Strait between Alaska and Russia. But first, I'm joined by Nicole Mortillaro. She's a senior science reporter with CBC News and is with me here in our Toronto studio. Nicole, good morning.
Good morning.
What is the AMOC?
It's part of a global ocean circulation. So it's a conveyor belt. And this conveyor belt, we look at the Gulf Stream specifically, where it's taking warm water from the south, from the Gulf, and it goes northward near Europe, and it sinks. It freezes first, and it becomes salty, and it sinks. And so that is actually behind why, the weather in St. John's, Newfoundland, and it's another city in like France, for example, they have very, very different climates because it moderates it brings warmer weather to Europe. And so it's a really important part of the ocean circulation.
And it's beyond just weather, right?
Oh, absolutely. It's climate. It's climate. And, then there are other consequences, of course, with ecosystems and animals and fish in the ocean that it actually affects too. How
much is the conveyor belt slowing down?
Well, there's a lot of disagreement there. So specifically, people are looking at it slowing down by 2,100.
2,100?
The year, yes. And so there's a lot of discussion out there. There are studies that come out often saying it's not going to collapse or it's not going to slow down or that it is going to slow down. Now, there is some slowing down already. Some scientists don't know whether it's part of a natural occurrence or how much of that is, because they only started studying it since 2004. Right? So it's pretty, actually, which is funny because that was the year that movie came out.
Yeah.
And so recent study found that it could slow down by as much as 50% by the end of the century.
And if that were to happen, we heard the trailer for the movie, you look at this online and the clips for people explaining this on YouTube or bye-bye humanity and things like that. You roll your eyes when some of that wildness is voiced. But what are the impacts of the AMOC, this global conveyor belt, climate conveyor belt slowing down?
So it would bring, obviously, cooler temperatures to Europe. It wouldn't be like the day after tomorrow where everything froze. If you got outside, you'd freeze instantly. There are studies saying that, it could be, for example, in London, they could see lows as low as minus 20 degrees Celsius.
Which very rarely, if ever, happens.
Exactly. But they would still have warm summers. Like global warming wouldn't stop. It would just slow down a little bit or, not as fast as it's going right now. And then sea level rise. That's the other issue. Now, one study said that it could be as much as or as little as 25 centimeters on the coast, for example, of Newfoundland. Sounds very minor, right? Well, what happens when there's storm surge? What happens to infrastructure there? So these consequences are going to be felt for sure.
And how is our changing climate impacting this?
So the experts, the scientists that I spoke with, wanted to stress that what is playing a part right now is climate change and the warming oceans. It's not the fresh water, because that's a concern. If fresh water melt from the Greenland ice sheets going to the ocean, that actually contributes to it. But they said that it contributes to it. It's not what we're seeing right now. What we're seeing right now is that the warmer waters, it's becoming less salty. It's less salty. It's not as dense. It doesn't sink. So that's what's happening right now.
And that leads to a rise in sea levels.
Yes. I mean, that's with with it slowing down.
Right.
Yeah.
And the timeline To your point, is there agreement on if and when this is going to happen?
No, not at all, actually. There was this study, I spoke to a scientist out of the Potsdam Institute, and he said that this study, the recent study that found it to be 50%, plus or minus 8% margin of error, is very robust, this study. There were other studies that had it slowing down by 30%, but with a margin of error of 37%.
Goodness. Okay.
Right. So this recent study seems to consider it somewhat robust, but I hate to say the cliche, wait and see. There's probably going to be another study in another 6 months.
And you mentioned, the possibility of rising sea levels, for example, in Newfoundland. What else might this mean for us here in Canada?
We would be cooler as well, not necessarily by a lot. I think they said it would be like a couple of degrees. But, and again, what would our winters look like, in places that are, it would affect the Northern Hemisphere as a whole and bring temperatures down. But climate change is still happening. We're still pumping fossil fuels into the atmosphere. We're creating this, rising temperature, this global warming. It would still happen, but it would just be a little bit slower.
And what about the more global consequences of something like this, the broader global consequences?
It would mainly be felt in the Northern Hemisphere. Mm-hmm. And I have to kind of chuckle at the day after tomorrow. One of the scenes that stood out to me was all the people from presumably Canada and the United States are rushing at the Mexican border trying to get in because it's not as cold there. And that's part of the concern. What happens geopolitically? What happens if, people don't want to live in Europe where it's cold, where it's minus 20?
This idea of climate migration.
Yeah, climate refugees. And so that's a big concern. It's a geopolitical concern more than maybe a climatic one for the rest of the world.
And so what can we do about this? We're going to talk more about this idea of damming the Bering Strait. But what can we do about this?
Well, the first thing we have to do is stop pumping fossil fuels into the atmosphere. That is what we can do. Disturbingly to me, we talk about the warming of the oceans, and in the IPCC report, they said that the changes that we're seeing right now in the oceans will last for millennia. To me, that was very disturbing. So, we can't stop it right now. It has momentum, but we can try to stop using fossil fuels and getting off fossil fuels and trying to, slow it down.
What about some of those mitigation ideas? What do you make of those?
This one that you're about to talk about, it's a thought experiment, which is interesting. And that focuses on the melting freshwater. It doesn't deal with the warming temperatures. So I think, and then the other thing is, of course, we don't know the consequences. It's geoengineering, and we don't know. With geoengineering is somewhat risky because we don't know the smaller effects.
That if you do one thing, there could be all sorts of the butterfly effect of other things.
Exactly. How is that going to affect the local ecosystems? How is that going to affect? That's the issue with geoengineering. But we can come up with these grandiose ideas, but we're the problem, and we really need to try and get off fossil fuels and stop global warming, or at least slow it down. What is
the story really about, do you think? It's about this thing, but more broadly, what is this about? If we take a look at the planet that we're on right now and the way that it's changing, do you see this as fitting into? We talk about climate change. We talk about what the climate change is doing to our planet. People worry about this. They worry about the jet stream. They worry about rising sea levels. Do you see what's the connection between all of that? Do you think?
Us.
Yeah.
It's how we are. We as human beings on this planet, we have changed it dramatically. With very little thought to consequences. We don't think long term. We tend to think short term. I really have come to appreciate the Indigenous culture where it's, thinking 7 years in advance.
7 generations.
Yeah, 7 generations. And, I have to think if we had thought in that way, perhaps we wouldn't be where we are now. But we are doing geoengineering. This is our experiment. And we are changing the planet drastically.
Nicole, thank you.
Thank you.
Nicole Mortillaro is a senior science reporter with CBC News. She was with me here in our Toronto studio. So what do we do about this? Could a dam on the other side of the world help stabilize the AMOC? A new study looks at the idea of damming the Bering Strait between Alaska and Russia. Jelle Soons is a PhD candidate at the Institute for Marine and Atmospheric Research, Utrecht, in the Netherlands, co-author of that study. Jelle Soons, hello to you.
Hi.
The Bering Strait is nowhere near the Atlantic. How would building a dam there impact the AMOC?
So through the Bering Strait, there is a flow of fresh water originating from the Pacific into the Arctic, and then in turn eventually ends up into the North Atlantic. And it is this North Atlantic region that's critical for the AMOC. And by preventing this flow through the Bering Strait, you in turn prevent this fresh water from ending up into the North Atlantic, which densifies the surface waters there, and that stabilizes the AMOC again.
Explain how that would work. What would that do? And I want to talk about what this dam would look like, etc. But what would that do to counter some of the things that Nicole has been talking about?
So why the AMOC would weaken or collapses on the climate change is because the surface waters in the North Atlantic become too light. So we know that fresher water is lighter and warmer water is lighter than more saline or colder water. So when we warm the climate, the surface waters of the North Atlantic become too warm, too light, and they don't sink anymore. And it is this sinking that keeps the AMOC going. So what we do by blocking this strait is we reduce the amount of fresh water that ends up into the surface of the North Atlantic. So we prevent lighter water from entering this region, and therefore the water in this region is still able to sink and keep the AMOC going.
So how do you build a dam across the Bering Strait?
Yeah, I wouldn't know. I'm not an engineer. This idea was really. So when I looked into the dimensions of the Bering Strait, I really did like a back of the envelope calculation by comparing it to other mega projects, and it was in the same order of magnitude. So yeah, my thought was just like, seems doable, and that's the end of my thought process, considering the actual building of the dam.
It's about 85 kilometers wide, the Bering Strait is. Is there a dam on Earth that is that size?
Well, you have the two islands, the Diomedes in the middle. So one is Russian and the other one is American. So this divides the strait into two sections of roughly 40 kilometers. The longest dam that we have built in the sea is in South Korea, and that's 33 kilometers. So, if you view them separately, it's in the same order of magnitude, as I said. You
have said that this, and it's whether that's possible or not is another matter, I suppose, but you've said that this dam could be an option in a worst-case scenario. What does the worst-case scenario look like for the AMOC, for this, as we keep calling it, the conveyor belt that helps in some ways stabilize the global climate?
Well, of course, the worst-case scenario would be a total collapse of the AMOC. The AMOC is a huge regulator of the global climate, and it mainly impacts the northern hemisphere by giving Europe a milder climate, and a collapse would, of course, raise the sea levels in the North Atlantic. But on the other hand, it also transports heat from the southern hemisphere to the northern hemisphere. So collapse of the AMOC would also add additional warming to the southern hemisphere and then increase the melt of Antarctica. And also the tropical rain belt that we have would shift. So there are also concerns that an AMOC collapse would impact the Amazon. They call it the so-called dieback of the Amazon, so that the Amazon itself could also tip. These are all, of course, like very active areas of research, but these are possible consequences that people talk about when they talk about an AMOC collapse.
How possible? None of those sound particularly good. They all sound the opposite of good. How possible do you think those scenarios are?
Well, that's a very active area of research. That's very uncertain. We don't know. It has been seen in some state-of-the-art models, but other models only show a weakening, and then after centuries, a gradual recovery. It is in the realm of possibilities, but we're not sure whether it's going to happen with our current emission scenarios.
Is that why an idea as out there as damming the Bering Strait, you think needs to be at the very least discussed, if not considered?
When you talk about geoengineering in general, there's always this debate on whether we should even research it. And one of the main arguments is that we should research it because we need to know what happens when we are actually in these scenarios where we might need to implement it. And I think this is also the case for Bering Strait Dam. You want to research it, what are the consequences when you are in such a worst case scenario where you have run out of reasonable options. So you start thinking about these things.
What are and Nicole talked a little bit about this, what are the unintended consequences of something like this, of building a dam like this?
The main impact of a dam would be on the region itself, on the Bering Sea region itself. So what you see is, because you block this fresh water from leaving the Pacific, is that you see a freshening of the water just south of the dam, and also an increase in sea level over there of like, at least in my model, that was roughly 20 centimeters. Ecologically speaking, and I'm not an ecologist, so this is not my expertise, but this route is used as a migration route for sea mammals and fish. And of course, it's used for shipping to supply these remote Arctic communities. So it hugely impacts that region.
I mean, part of this is about that idea of geoengineering to address climate change. And people may have heard of ideas. You put up a giant space umbrella. You refreeze some of the melting Arctic ice with these huge pumps, that you put up space mirrors to reflect sunlight away from Earth and perhaps slow the warming of the planet. What does it tell you that we are even talking about these issues in the context of fighting against climate change?
Well, that it's, these are all, including my dam, kind of ridiculous proposals, right? Which tells us that we're already in a kind of ridiculous situation, I think. We have been telling the public and warning the public about climate change for decades, and still emissions are rising. So then we start thinking about, other options, and then you get to stuff like this.
If we aren't going to go to stuff like this and these other options, what do you think can be done to stabilize this really important part of our natural world?
Well, apart from the obvious, reducing fossil fuel emissions, there are other geoengineering options that are very experimental and new. I mean, those are options, right?
But at the root of it, you believe, as Nicole does, that this is about getting off of oil and gas, that if we don't do that, those other far out geoengineering ideas are going to have to be at the very least considered.
But that's because we have nowhere else to go at that point.
This is alarming and really interesting as well. Jelle Soons, good to speak with you. Thank you very much.
Thank you.
Jelle Soons is a PhD candidate at the Institute for Marine and Atmospheric Research, Utrecht University in the Netherlands. You've been listening to The Current Podcast. My name is Matt Galloway. Thanks for listening. I'll talk to you soon.